Hey everybody, I was wondering to see how I can explain the cost of LLM, the computation of LLM, why they cost a lot. One of the reason, which is a memory operation. I was trying to explain that all of these big models they have this issue, which is, and specifically this issue arises at the generation phase. So when your model did the training, he actually trained, and now you are going to generate a token. You are going to generate a word. At this time, you have another bottleneck, another limitation, another thing which caused the model to cost a lot for you, which is the bandwidth. Here, as you can see, from starting of setting the bytes, for example, you can see you have your model have many weights, which they are patterns which your model learned during the training. Those weights they have to be loaded into the memory. They have to be loaded, and they are numbers. And then for the generating of one token, we have to fetch those bytes from memory and load them into the computation unit, for example, CPU or GPU. And then the core of the GPU or CPU will does the computation. But the computation unit here waiting all the time for the memory to transfer those data from memory to the computation unit, to the GPU or CPU or the core itself. And that time takes a lot. So you can imagine that for all the tokens, for all of your text that you, for example, you generate the next token, and then for 7 billion model, for a 7 billion model, it has to fetch 40 gigabytes of data for the 7 billion model for every word. So it takes a lot. For example, look at this. With every generation of word, how much byte it needs to transfer, it needs to move from memory to computation unit. It's a lot. So you can imagine that if you increase the size of model like here's 175 billion, this number is insane. So most of the time of the model is waiting for memory to transfer data from memory into the computation unit. And this is the 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 bottleneck and the hard part. And also this movement generate heat, and it needs energy. And you can see the difference of the time. This is why we need to wait a lot for generating one token. For example, here memory transfer takes 116 milliseconds, but computation takes around less than 1 millisecond. So here you can see instantly, as soon as data arrives, the computation will take effect, because the computation itself, it's a matrix multiplication, and it's really easy. The transferring the data is very hard. It takes time because there are a lot of data to transfer. Again, I emphasize on the fact that this is uh, for the generation phase of the this process. So generating the token takes all of these things. It is not compute bound. But for the training phase, it's a different story. It is compute bound in the training phase. And the fact that for generation of every token, every word, we move through whole weights of the model. We need to fetch the whole weights, the whole model, refresh every word. This fact is for the standard dense model. For the mixture of expert model, the architect, these are a new architecture, mixture of expert, it's a little bit different because when we are generating the token, some somewhere in the middle of the generation, there's a classifier which decide to go another route inside the model, and that decision, for example, it takes from three route, it takes one of them. So other two routes, the weights of other two routes will be deactivated. We, we will not use them, so they will be shut off. So we cannot say that in the mixture of expert model we use all of the weights during every word generation. So actually, mixture of expert decrease the this reading, but we are still bounded by this memory transferring. So that's why we are trying to decrease this reading from the weights, or write the code very very cache friendly when you are trying to write the engine for inference, and to make your model very fast you have a cache system for the KV cache, and all of these techniques to make all of these things faster on the same hardware, because one of these two things have it has to catch up, or the hardware they have to be faster in the moving the data, or the software part they have to be much more intelligent and much more smarter. So yeah, this is the reason in the generation it costs a lot and it's slow in the generation phase, but in the training the story is different. Thanks for watching.